In this video, I'm going to cover the survey feature definition from a perspective of, the connectivity and how to basically create one from scratch. Now, you may not do this when you're doing your initial configuration. More likely, you may be doing it in a bulk way through the XIN extractor or and ultimately through a spreadsheet and XML files. But you should know how the different pieces of the OpenRoads configuration tie together and relate to each other relative to a feature definition. So let's just cover a survey feature definition, and after this video, you should be able to just add your own codes, field codes, into the feature definition configuration. So let's just get started here. Now I'm on OpenRoads 2021 R1. There really hasn't been much change in the past few years. There may be some new tools coming out in newer versions that make this a little bit easier, but fundamentally what I'm going to cover, I don't necessarily see it changing, and it has related to the recent past anyway. Now I'm in a DGN file that has a field book, some data in it already. So I do have in here some survey data that I brought in that has some information. This is basically in the Zen survey training. So for those of you that have taken the Zen survey training, this would be familiar to you. So this is the information that I use in my Zen OpenRoads survey book. So I'm in this DGN file. Now, normally you wouldn't necessarily create a new code in here unless it was a one-off that related to this specific project. If you're doing something, adding something that needed to be used down the road in other surveys, then you would have to do it in the DGN lib that stores those sort of in the backstage area, the back configuration. So if you're doing configuration, you have access to those DGN libs, then that's the file, wherever the survey feature definitions are stored, that's the file that you would be building this in. Just for the sake of discussion and illustration, I'm just going to do it in this active DGN file. But again, you wouldn't normally do it there. Now, in my book, I cover in the primer and also in the survey book itself, sort of the breadcrumb trail of those elements of OpenRoads and leading ultimately to MicroStation, how they tie together to create the feature definition, or the things that at least weave together with the feature definition. Now, if you look at this diagram and focus on the yellow ovals, we'll start and then I'll go to the software and show you. So we're building a feature definition. So here on the left side, the feature definition, and specifically this one is for a point. We're going to do a line, but the thread's the same. So the feature definition is connected to a feature symbology. So the feature symbology is the next, I'll say, major component in the creation of a new code. And from a survey perspective, that's really what we're looking at. We're talking about how to build a new code that can be used in the field and then integrated into the post-processing mechanism. Now, from an engineering perspective, very similar, except it's not really for the field. It's for the user to define if he's building a edge of shoulder, a new edge of shoulder, or a new center line, or a something. They're still going to pick a feature definition. It's going to have these same aspects to it and this same, I'll say, breadcrumb trail. So the feature definition is connected to a feature symbology. Again, I'll show you that when we get into the software. The feature symbology, you have to look at that as a junction box. It splits and forks into two different ways. One, it forks into the element template, and the element template, following that thread down, ultimately ties to MicroStation, the level, color, line style, cells, if there's cells, all that. So the element template is really the connection point between the OpenRoads configuration and MicroStation. Now, the other aspect of this feature symbology junction box is basically the annotation group. So it splits there. So if this item that you're creating has an annotation associated with it, that annotation has to be built separately and then connected at the point of the features through the feature symbology. So the feature definition is connected to the feature symbology. The feature symbology is a junction box. One of the branches is how it ties and weaves to MicroStation and the display, the graphical display, and then the other branch leads to the annotation group, where you build the annotation definitions and any textual pieces that would be associated with that. For instance, if we were doing an alignment, a center line, and you may have the bearing and distance on there, or it's a alignment and you want the stationing on there. The stationing would be set up within and built in construction in this annotation group branch and then connected to the feature symbology. When we get into the software, I'll kind of show that. So this is really what we're going to be looking at. We're not going to look at the annotation in this video and maybe in an upcoming video. Right now, we're going to look at the basic sort of fundamental thread that all feature definitions have, that goes to the feature definition, connected to the feature symbology, connected to the element template, which ties it to the MicroStation engine. So with that, let's look at this here in the software. So in the Explorer window, this is the survey where you look into the field book. So we're going to go into the OpenRoads standards. Now, the OpenRoads standards, and this is repetition if you've been in one of our Zen classes, whether it's drainage or the modeling or the geometry or the survey. We talk about this, and it's covered in the primer, which is fundamental, the first volume on all those classes. But the standards are held generally in libraries. So in the libraries, if you expand that, this is what's tied in the back. You notice they're gray, so they're read-only, so you can't actually go in here and build it. That's why we're going to build it in the active file. Otherwise, we'd have to open up some of the DGN lives. So here you could see the feature definitions and the feature symbologies. This is what we're going to be looking at in this video. Now, the annotation groups and annotation definition, that's that other branch. We're not going to look at that right now. So the feature definitions, if we just kind of look at that from the configuration, the back engine kind of behind the curtain, you'll see that the feature definitions in my configuration, this is the Zen configuration, is being pulled from two DGN libs, and you can see the names right here. So the Zen DU main FD, feature definition DGN lib, and the Zen main FD DGN lib. So the feature definitions are stored in here. Now, if you open up the feature symbologies, they can be pulled from somewhere else. In our case, they're pulled from the same location. So these are in the same file. And in this illustration, we're going to build them in the same file. They can exist in the same file, and it's pretty typical that they do. So if we expand this DGN lib, then you'll see all the various types of feature definitions. Again, we're looking at the feature definitions here in this DGN lib. So what we're going to be focusing on are those in the survey category. Okay. So let's kind of back out of the general standards, or the standards, the corporate standards, and let's look at this active DGN file. Now, in the active DGN file, when you're working in survey, the codes that are used in the field when something is post-processed are copied physically into this DGN file. Once they're in the actual DGN file, then the display is actually driven from the feature definition as it exists in the DGN file. It can be changed in that DGN file and become different, I'll say, from the standards. Typically, you wouldn't want to do that, and there are mechanisms to sync it. So if we look at this particular job that I'm working on here, this sample training exercise. If I look in here, these are all feature definitions that have been copied into this DGN file, and notice that they are bold. You know, they're live. They're not grayed out, meaning that they're read only. These are read write. So these are all codes that have been used, within this survey. So and they are organized in folders and subfolders. It's very free form. The name, the folders and subfolders, and the levels of subfolders, that's completely up to you. The name of it is completely up to you, although I tend to like to use a common thematic naming convention so that you could see them and locate them more easily, from the feature definition to the feature symbology to the element template, and you'll see sort of how I organize it. Again, there's nothing magical about what I did. It's something that you just have to organize in such a way that is at least intuitive from your perspective as you go in here and navigate this. So these are the survey feature definitions that are live in this particular DGN file here that I'm in. If I look at under any category, you'll see the specific codes. Now, the way that I named it is I have the alpha code. This was collected using alpha codes, not numerics. So the alpha code, I just tagged it onto the name on the end of the formal name, so to speak. And that was really just for familiarity, for comfort, for me to be able to look at it and know at a glance what that code was. That's optional. These names, again, are free form. You could call it whatever you want. So here we have, and let's just look at one of these, and let's just say this concrete curb. So in this case, it's called VF. Now, the naming convention I use is sort of a pseudo National CAD standards, a discipline code dash 4-character major code identifier. And then I use basically a dash and a free form. You could use whatever naming convention you want. And I do recommend that you have some sort of naming convention developed, and you're not just adding them in, and it seems really out of place. So in this case, it's a field, existing field code, usually C for civil or design, V for existing. I usually use VF to show that it's a field existing code. So if we look at this VF road concrete curb, and we look at its properties, and open up, I'm going to pin these properties here. If you look at the properties have basically these 4 categories. Under the feature definition category is the name, description, and a seed. And the seed is when it's used in OpenRoads, it is giving it an actual name. If there's multiples, it tags, a number on there, 1, 2, 3, 4, if there's multiples. Under the survey feature is where it's defining how it's used or integrated into the terrain. And there's all the different terrain point types. Again, those are, I'm not going to cover them here. That's in my material, that's in my training. Some of these are I'm going to say self-explanatory if you understood surfaces or even the DTM, InRoads DTM in the past. They're not so far off that you wouldn't know what they were. But you'd have to go in here and obviously understand, which one you want to use. So this is how it's used in the surface model. And so the zone is basically an arbitrary number that you can use to categorize that day or the usage of this code. And it's a way to just segregate it from others. I'm not going to apply it here. It's, I would say, more of an advanced topic. Then, of course, alpha code, numeric code. And then items is the item types. Again, that's also an advanced thing. It's basically additional attributes that a user can define on there. They have to be pulled from an external source. I don't have those set up. So I'm not using those here. And then the symbology, and this is where I want to kind of, show the thread, and then we're going to kind of circle back to this when we actually create it. Right now, I just want to give you an illustration of the connectivity to sort of dovetail in with that diagram that I was showing earlier. So the symbology is how this item displays or is viewed as a line and how it's viewed as a point. Now, in this case, this concrete curb, it has a line symbology, feature symbology to display it in such a way as a linear entity, but it also has a point symbology, which is basically just a general point, so that there's basically a tick mark or a dot or a whatever at each physical shot that's taken. That's optional. That's up to you. It all depends on how your standards are. And really, the intent of this is just to replicate what you've been doing and allow OpenRoads to do what you've always done. Now, obviously, there's this functionality that you could say, hey, from now on, we're going to start putting a little tick or a dot or a something on a non-plot level or something, just so that we could see where each shot is. And it's something that you could kind of enhance your standards if you have that interest. But so here's this connectivity. So the feature definition is connected to feature symbologies. And in this case, it's connected, let's follow this one thread. It's connected to this linear feature symbology called V-Road Curb Gutter Flow Line, okay? And let's kind of pay attention to that, because sometimes these may not, the naming convention might not be thematically connected up. So, and in some cases, I know that I opted not to do that. And it's a good illustration so that you could try to, how do you follow the breadcrumb trail? So let's look for then the feature symbology called V-Road Curb Gutter Flow Line, CGF. So we're going to go into the standard. We're in the standards here. And this is, we were in the feature definitions. So we're going to go to the feature symbologies. And this is a linear, because it's a linear feature symbology. And it's under here, existing roadway. And this is where you do have to have some familiarity with the organizational piece of this, because it can have folders and subfolders and subfolders and subfolders. Organizationally, there's no rigid structure. It's really freeform. So let's look at this V-Road Curb Gutter Flow Line. So V-Road Curb Gutter Flow Line right here, CGF. So this feature definition is tied to this feature symbology. So I'm going to select this feature symbology here. And these are now the settings. I mean, you could, if you right click and look at its properties, that's what we're looking at here, the properties of this feature symbology. This feature symbology, if you remember from that diagram, the feature definition is connected to the feature symbology, which is connected to the element template and any annotation. So right now, when we're focusing on the element template to really tie it into the MicroStation engine. So this is where we're looking at the feature symbology now, and it's the element templates. The default element template is here, the existing roadway, V-Road Curb Gutter Flow Line, CGF. So let's look at the element templates. I just have a shortcut here for my element templates. Again, we're in the active drawing, so that's the one with the icon that is live. The other one, grays, are in our DGN lives. So let's look at this existing and follow this path, existing roadway. So under the roadway, and then a V-Road Curb Gutter. Let's put this up a bit. So V-Road Curb Gutter, and it is, the flow line. Okay, so that is this one right here. So this then says what level it's going to go on, what's its color, line style, and weight. So this kind of goes full circle. So it has the feature definition that is connected to this feature symbology, and this feature symbology is tied to this element template that basically says, here's how you draw that. Now, looking at this a little bit here, this is I set this up as the default. So in all instances, this element template is what's going to drive the display of this feature definition, that code that we're using, how it's going to look in all environments. You can set up a specific element template for how it looks in plan view. You can actually set up something different if you're doing geometry. Maybe this is a feature definition for geometry. You may have the arc a certain color. You may have the spiral set up as a different color. So this is a way to show some differentiation if you felt like in plan. This is also the annotation connection. So remember, the feature symbology here that we're looking at is a junction box. One of the things it does is points to the element template. The other thing that it points to is the annotation, if there were any annotation on here. So this is where it would connect up to any annotation that would have been pre-configured so that you could select that annotation and assign it or associate it with this, ultimately with this feature definition. So this doesn't have any annotation set up. And again, it's something I may cover in another video. So again, just to kind of reiterate some of this, the feature definition is connected to the feature symbology. The feature symbology is connected to the element template. It's saying, here's the element template that controls how it's drawn. From a default perspective, if you have only the default, it looks this way, just per this, it looks this way in all environments. But you can set it up differently to look a different way in plan, a different way in profile, a different way in 3D, and a different way in cross-section. So these are all options. It depends on how you want to utilize this item, this code, this field collected object, and how you want to display it in either plan, profile, cross-section, or in 3D. So I've made this generally simpler, and this is probably the best way to do it kind of initially until you really get your head wrapped around, well, do I want to show it differently in intersection? Do I want to profile? Do I want to show it differently in 3D? Do I want to show it differently in a cross-section or even in plan in its different aspects? Survey really doesn't apply here because you're not really building true curves in the field. So, it don't necessarily apply, or it'd be unusual that these would be drawn differently. I see this more in a design scenario where the plan, the tangent, the arc, and the spiral might have some different symbology associated with, just so that you could see it visually when you're doing that geometry. So this is kind of the connectivity. The feature definition tied to the feature symbology. Feature symbology is calling out the element template. The element template is tied to the microstation settings themselves. Okay, so now let's go ahead and build one. Now, you don't build it from the top down. You don't build it from the feature definition to the feature symbology to the element template. Basically, you have to build it from the bottom up, which means you need to have your microstation settings already established, already built into the file, accessible. So once the microstation resources are available, then you could build the element template. Once the element template's done, you could build the feature symbology and link it to that element template. Once you have the feature symbology done, then you could build the feature definition and link it to that feature symbology. The same way with, you'd have to set up the annotation settings in the annotation group and then set up the feature symbology and connect it together. So you have to build it from the bottom up, not from, the item that is most, I'll say, interface with the user, the feature definition, and that down. You have to go build it in reverse. So what we're going to do is let's build one for just the edge of dirt road. I noticed I have some in here on the road for edge of concrete road, a gravel road. So let's just build one for an edge of dirt, and I have an edge of asphalt. So let's do an existing edge of dirt road. Now, like I said, you need to have the microstation piece done first. So if we go to, and I'm gonna just change the workflow here to survey, since that's essentially what we're working in. And if I go to the home tab here, and this right here is the level manager, just to show what's available relative to the levels. Let's get that back out of there. So if we look at the levels here, these are all the levels that are available, and I'm just going to check to make sure that we have one for dirt road, because we're going to have to select it. In InRoads, you were able to just type in free form a level and it would just create it on the fly. That's not true for OpenRoads. In OpenRoads, you have to have all the resources done prior. including the levels. So if we look at the V road, okay, so there we go, V road dirt. And it's the color, line style, weight is already associated with it in this DGN lib. So all we have to do is connect it up to V road dirt, and we should be good there. So we're going to go to the roadway, and we're just going to create I'm just right clicking on this, or you can go up here to utilities, and nope, that's not there. Okay, it looks like, I think it's here. New template group right there, new template. So you could do new template from there. So I'm just going to right click on this and do a new template. We're going to call this V road and edge dirt road. Okay, so we've got that created, and the level, let's pick our level here, V road dirt, and we're going to leave the colors, line styles, and weights as by level. Of course, you could always go in here and override this and set it to whatever you want. They have custom line styles. So in this case, we're going to just leave these as by level. So that's created. The way the element template works too is once it's built, it's automatically saving constantly. It's like MicroStation. It just saves as you go in there and make a modification. So this now exists, V road, edge dirt road. Okay. And let's get out of there. So now we're going to go to the feature symbology. We're in this folder here. So I'm going to go and create a new category, new feature symbology. Okay. And we're going to do the same thing, V road. This is where you need to have a naming convention set up, predictable, so that you could just start to do this. I have, again, the discipline code dash, a 4-character major code, and then I have a little free form set of characters just to give a little bit more description. So edge dirt road. Okay. The names don't have to be the same, but to me it makes it a little bit more intuitive. Okay, so now this name is created, but you notice none of the settings over here. We look at the properties. None of the settings are established here. We're going to do this fairly simple, and we're just going to connect it up so that in plan, profile, cross, everything is being driven by this one element template. And we're going to go and browse. This is where you need to understand the folder structure and be comfortable with that. So it's under the existing roadway, and slide this here and look for our, there it is, V road edge dirt. Okay. All right, so that is now created. And the next step is the feature definition itself. So let's close the feature symbologies, go to the feature definitions, and this is a survey feature definition. If you were creating an alignment feature definition or a linear or points, you would do it up in here and expand it in here, but this is a survey and roadway. And we're going to put it under the roadway folder here with these other edges. Okay. And new feature definition. And we're going to call this VF per my naming convention, road. And then it is edge of dirt. And we're going to have an alpha code DRD, dirt road. So that is, and I'm capitalize it because the rest of them are capitalized. So whatever kind of theme, formatting, naming, try to, keep that so that they're all, consistent. I mean, if you wanted to do something unusual, have it pop, well, then go ahead and do that. This would be the time. All right, so once the name is done, then we just have to establish the settings of the feature definition itself. Okay. So the name, it's grayed out, so that's defined here. If you needed to change this name, you could right-click on it and rename it. You can't do it over here, so you can right click and rename it here. Okay. So then let's give this a description, and let's give it edge of dirt road. And the name seed, from a survey perspective, I usually use the alpha code or the numeric code. It could really be anything that you want. It's the name seed comes in when that item is used multiple times. It has to have a name, but the names can't be identical if they have an edge on one side and an edge on the other, or multiple edges. The names usually have a suffix 1, 2, 3, 4 attached to them, and that automatically does that. So it is, as it says, the category here is name seed, or the item is name seed. It is that, it's a seed. From a geometry perspective, you may have it just called, CL or alignment or geom. And if you kept using it in multiple alignments, it would be geom1, geom2, geom3, geom4. So I'm just going to use in here DRD, which is, I'm just using it as the same as the alpha code. The terrain model attribute, in this case, it's a linear entity, so I'm going to call it a break line. Again, these, you should be familiar with these. I have them defined in my book, so if you have my book, they're all in there. Zone, I know I've consistently just used all of these as zone 1. I haven't really differentiated or categorized them, so I just have everything as zone 1. At some point when I get into, or I find the value of using zones to, isolate the display, or report, or however you want to use this mechanism as an isolation mechanism, you can. Right now, to me, all the survey stuff is in one bucket, so I don't have the zones differentiated. Okay, the alpha code here, we are using DRD. And the numeric code, I do have numeric. I have alpha and numeric codes assigned to these. So I know that this is 103 is available, so I'm going to use a 103 here. Items, this, like I mentioned before, this is item types. It's an additional attribution. I'm not really using that. And then going back to our diagram here, the feature definition is connected to feature symbologies. The feature symbologies ultimately is connected to the element template to say how to draw it. So the feature definition, this is, again, you have to have the feature symbologies already established so that when you go in and build this, you could connect them up here. So this is the stage that we're in. We've built the element templates, we've built the feature symbology and connected it to this. Now we're building the feature definition and connecting it to the feature symbology. The feature symbology is either linear or points. So we have our feature symbology created here. I'm just going to go ahead and browse to it. It was under the existing and roadway, and you can see the ones. It's showing you the ability to browse into another DGN lib, another file. These things don't have to exist in the same file. And those ones that are gray, the ones that are colored, are live in reading it directly from this file here. So we are looking for the dirt road edge. And then in this case, and in the case of what I have configured for the Zen training workspace, is I've also been displacing a general point location at each of the shots themselves, just so it could be identified. So I do have an interest here in connecting it up to a feature symbology that is just set up for a general point. And all of the linear codes that I have set up, I just have a general point associated with it, just so that it could show up a shot, a location, a graphic, wherever that is physically shot. So that's it. That's the connectivity of the feature definition to the feature symbology. And then if we just kind of, back it off here, again, we're in the feature definition category here. If we look at the feature symbologies that we did of the dirt road, that is connected to the element template. The element template is connected to the actual microstation resources. So we have our dirt road connected to the resources there. And that is basically it. So I will potentially do some other videos showing how the annotation piece is set up. Remember, the feature symbology here is a junction box, so there is the ability to connect it up to some annotation. We'll kind of maybe circle back on that. The other aspect of codes, survey codes, is that they may have attributes. Attributes is another topic that I'll cover in another video later, but attributes in inroads were really part of the code itself. So you might have expected, and I know that I did, expected that the attributes would be part of the definition itself of the feature, because in inroads, when you created a style, and feature definitions are really I mean, it could have been saying inroad style when I say feature definition. The inroad style had a tab for the attributes, and the attributes then were leveraged or used in the custom operations, but they were actually part of that style. And in that style, you define, did it go in the surface? Was it excluded from the surface? How was it how was it drawn? What was the alpha code? What was the numeric code? And what were the attributes? So that was all part of the styles. That's not the way OpenRoads is. OpenRoads, the attribution of a code is not part of the construction of that code here. You really have to get into, and again, I'll do another video on this a little bit later, is the building a new code is really the feature definition, tied to the feature symbology, tied to the element templates, annotation as necessary. But the survey settings, and these survey settings, this is actually where the attribution takes place in terms of addressing the attributes, and they're called attribute overrides. So there's a lot of capability in here that I'll say was maybe part of the inroads style in inroads, but the survey options, so this is sort of a combination of some new functionality and the survey options, inroad survey options, and part of the, some of the custom operations and attributes of inroads is all really now built into the survey-based settings themselves. So in here is where there's the attribute overrides. And those attribute overrides are actually part of the general setting. So you can see these attribute overrides right here. So when your codes have attributes, they basically have to be defined here. So this is, I want to say separate, it is separate. It's separate from the actual feature definition coding itself. This is where you're basically saying, look, if you find a certain code, here's what you need to do. But it is set up differently, stored in a different location, and it's actually part of the survey settings as opposed to part of the code. So again, this is something that will be covered in another video. So that should be it. From this information, you should be able to create feature definitions from new codes that you want to introduce into your configuration. Just remember that if it's just part of this survey, you could do it in the survey itself, in that DGN file. But if you really want it to be part of future post-processing, it needs to be in the actual libraries, done in here in the libraries that are connected, kind of within the overall configuration itself. All right, so I hope that helped. If you have any questions, I'm sure you could know how to contact me.